All right, guys, let's take a look at this review. Okay, this is asking us to find the zeros or the solutions of the functions below, and we're going to do this by factoring. All right, so let's see. Always when you're factoring, the first thing you want to do is see if there's a GCF. This has an x squared in each term. Okay, so that leaves me with x squared plus 12x plus 36. And then I keep going. What multiplies to make 36 and adds to make 12 is plus 6 plus 6. And of course, you know, another way that we could write that is x plus 6 squared. If you wanted to, you don't have to. But we know that this gives us a solution of 0. Now, because of the squared right here, it means we actually get that answer twice. You are welcome to write 0 twice like that, or you can write that it has a multiplicity of 2. And then here and here I get negative 6. Again, I get it twice, so you can write it twice, or a multiplicity of 2. Okay. Number 2 also has a GCF, x to the third. I get x squared minus 9. And then that is a difference of squares. So I get x plus 3, x minus 3. Okay. So my solutions are 0. Now this time it's to the third. So I'm going to say it as a multiplicity of 3, negative 3, and positive 3. Okay? Okay, perfect. Next, this one has just a GCF of x. And then I have to factor this. Remember the way that you do this when there's a number in front. You can either do 4x and 1x or 2x and 2x. You got to decide. And then for 25, we can do 5 and 5, 1 and 25, okay? Now, the key is I'm going to do it the wrong way first, just so you guys can kind of see it. The outside and the inside have to add up to make the middle. Well, 20 and 5 make 25, not 20. So you kind of just keep switching it around. You could try 25 and 1, which doesn't work. That's like 29. You know, and then you can also switch this first number around, which is what it ends up being, 2x and 2x, 5 times 5. Now, the reason that works is because that gives me 10x on the outside, 10x on the inside. Okay? So, and in order to get negative 20, they would both be negative. Look a little bit better. Okay, and so my zeros are 0. And remember, when you're solving these, we add 5, divide by 2. So positive 5 over 2, and we got that answer 2 times. All right? Okay, this last one, the only thing I could take out is a 2x squared. That leaves me with 9x squared minus 6x plus 1. And then with this, we could split it up to 3 and 3 or 9 and 1. I think this one, 3 and 3 works. This, there's only one way to split it up. 1 and 1, minus and minus. Okay? And so when I set that equal to 0, from this first one, I get 0. Because you guys, if you divide 2 and take the square root, it's still 0. So I get 0 with a multiplicity of 2. And then when I solve those, I get 1/3. That also has a multiplicity of 2. Okay? All right, perfect. Set these equal to 0. Okay, great. Now, on your test, this part with the multiplicities and the effect that they have on the graph. All right, so what we're going to do is there'll be like a little box on your test that asks for what the solution is, its multiplicity, and the effect on the graph. Okay? So for this one, the solution there is 0, the solution there is 1/5, and the solution there is negative 3/4. All right? This one has a multiplicity of 5. This one has a multiplicity of 2. And this one has a multiplicity of 3, which means that's how many times each of those occur. Okay? Now we're going to go look at the graph of this. You're not going to do any graphing on the test. I just want you guys to see it. So let me pull that up real quick. Okay, guys, so here's our graph now. This is kind of crazy, so I'm going to like zoom in on it a little bit. Make it look a little bit more like that. And actually, I like really have to zoom in on this next part. This isn't the best graph to look at. But anyways, at this solution, -3/4, that is what we call a flat cross. Okay? And that was that solution at -3/4. And it actually bounces right here at 0. It's like nearly impossible to see it. Oh, here we go. Here we go. You just have to like majorly zoom in. Actually, it doesn't bounce at 0. It does a flat cross at 0, right? And it bounces at 1/5. I just had to like big time zoom in to see all those. Okay? That's a good zoom that you can see how that happens. All right. So now you don't have to include the word flat. I do because I know it crosses like flat. Anything that's odd multiplicity, we'll do a flat cross, and anything even will bounce. Okay? Now this next one, we have to factor it before we can, determine our zeros because this one's not factored out. Okay, I can take out a 3x, and I'm left with 4x squared plus 36 divided by 3 is 12x plus 9. And then that factors to 2x plus 3, 2x plus 3. Okay, so the zeros on here are 0, -3/2, and -3/2. We don't use that row, okay? And the 0 has a multiplicity of 1, and the -3/2 has a multiplicity of 2 because we saw that twice. So it's going to do just normal cross here. And this one will have a bounce. Okay? So let's take a look at this. So this one's like a little bit better to see. I can like zoom in a bit. But you can see it crosses at 0 and it bounces at -3/2, -1.5. Okay? But again, you're not graphing. We're just talking about the effect that it has on the graph. All right. Perfect. Next page. There will be 2 questions on your test where you have to use long division. All right. Yeah, it's because like if you have an x squared or if you're dividing by a trinomial with 3 terms, and then it's because of that 5 right there too. Okay? All right, so let's take a look. Okay, so I'm going to do long division with 2x squared plus 5x plus 6. So what you do, guys, is you start by just looking at the first terms, okay? And you go, how many times does 2x squared go into 10x to the third? Well, 2 times 5 is 10. X squared times x is x to the third. Now, you have to distribute that to all 3 parts. We have to go 10x to the third plus 25x squared plus 30x. Okay, now this step is really important. We change the sign. So each of those change to minus. All right. And this becomes, okay, 19 minus 25 is -6x squared, and 15 minus 30 is -15x. And then you bring down the 11, and you do the whole thing again. Well, you always start off by saying 2x squared goes into -6x squared how many times? So I'd have to multiply by -3. So that gives me -6x squared. That gives me -15x. And then that gives me -18. When I switch the signs of each of those, actually those 2 both cancel out, and I just get a remainder of 7. Okay? So here's how you write your answer. So you take what's on the top, all right, 5x minus 3, and then you put the remainder over the thing that you were dividing by. Because there's 7 of those left. 7 of 2x squared plus 5x plus 6. Okay? Okay, great. Next, Now we did learn that even with long division, you have to use every exponent. So if it starts with x to the fourth, it's got to go x fourth, x to the third, x squared, x, and x 0. This one didn't have a 0 term. Okay, so I go like this. All right. 5x goes into 10x to the fourth, 2x to the third times. Okay, so that's 10x to the fourth. That's 4x to the third. Change my signs. That's 0. And I get negative 20x to the third. And then I bring down 12x squared. And then I do the whole thing again, okay? So start with 5x. Goes to negative 20x to the third, negative 4x squared times. So that gives me negative 20x to the third, negative 8x squared. Okay, change the signs. That cancels. And this gives me 20x squared, and I bring down the 23x. Oh, I'm going to run out of room on this. Okay. 5x times what is 20x squared? So that's going to be times 4x. That gives me 20x squared. That gives me 8x. Okay, I change the sign. That cancels. And then 23 minus 8 is 15. Yeah, 15. And I bring down the 0, and then this is my last step, okay? 5x goes into 15x 3 times. When I distribute that, I get 15x plus 6. Subtract that. And I have a remainder of negative 6. Okay? So let's look at how you write the answer for this. My goodness, I have like no space. All right, move it over to here. Make it a little bit smaller. There you go. Okay, so the answer is 2x to the third minus 4x squared plus 4x plus 3. And then the remainder, negative 6 over, give myself enough room there, the thing I was dividing by, 5x plus 2. Okay? Whew! So make sure you feel good on long division. That'll be 2 questions. All right. Next, synthetic division. We all love synthetic division. The only thing you got to remember, you guys, is that the number you use is the opposite of what you see here, because we're using the solution, not the factor, okay? So like this one is 4 into 3, negative 6, negative 20, negative 7. All right, we like this a ton better. We go like this. 3 times 4 is 12, that's 6. 6 times 4 is 24, that's 4. 4 times 4 is 16, that's 9. Now, since the directions just say divide, it wants you to just write an equation, write your whole answer. So here's what I get. Remember, if it starts off as x to the third, it goes down 1. So it's 3x squared plus 6x plus 4. And then that's the remainder, 9 over the thing that I was dividing by, which is up there. So 9 over x minus 4. Okay. Okay, for number 2, I'm doing negative 1 into 2, 9, 10, 13. Okay, so here are the steps. Bring the 2 down. 2 times negative 1 is negative 2. Add those together, that's 7. 7 times negative 1 is negative 7. Add those together, that's 3. 3 times 1 is negative 3. Add those together, that's 10. Again, this was an x to the third, so this is going to be 2x squared plus 7x plus 3, and then the remainder over the thing we were dividing by, 10 over x plus 1. All right. One more synthetic division. You got to pay attention on this one because we are missing a term, okay? So we have 6x to the 5th. Move this down a little bit. All right. Minus 16x to the 4th. Minus 14x to the 3rd. Plus 28x squared. Then we have 0x minus 29. Okay, bring the 6 down. And then we multiply. 6 times 3 is 18. That's 2. Multiply. 2 times 3 is 6. That's negative 8. Multiply. Negative 8 times 3 is negative 24. That's 4. Multiply that. 4 times 3 is 12. That's 12. And then multiply that. 12 times 3 is 36. That's 7. All right. This was an x to the 5th, so my answer is going to be an x to the 4th. 6x to the 4th plus 2x to the 3rd minus 8x squared plus 4x plus 12. And then we have 7 over, let's see, the remainder over the thing we were dividing by, x minus 3. All right? Cool. Okay, guys, the next section, we are still using the remainder theorem. We're just like, you got to answer the questions a little bit different, or we're still using synthetic division, I should say. The remainder theorem means I take this number right here. I don't have to change the sign because it just says c equals 2. It's not like a factor, okay? I take that number and I do synthetic division. Okay, 4 times 2 is 8. Negative 5 plus 8 is 3. 3 times 2 is 6. 4 plus 6 is 10. 10 times 2 is 12. 4 plus 12 is 16. That is your answer, okay? Now, there is a way that you can check this. Okay, so anytime you want to check a synthetic division problem, what you're doing is basically just plugging 2 into this equation, okay? So I can go, let's see, it was 4 times 2 to the 3rd minus 5 times 2 squared plus 4 times 2 plus 4. And we get 24, which is excellent because that means I did something wrong. Okay, and that's good. You guys probably already saw my mistake. I'm like kind of tired right now, which means I got to be very careful. And I got 24, so it's really good that I went back and checked. Let's pretend like I did that for a nice learning lesson. I already see my mistake right here. Did you guys see when I did that? 10 times 2 is not 12. My goodness. 10 times 2 is 20, which makes 24, which is what I did here. So if you're prone to making mistakes like me, I would recommend checking your synthetic division on a calculator. All right? All right, let's try this next one. Okay, now I'm doing negative 4 into 1, 1, negative 5, 3. 1 times negative 4 is negative 4. That's negative 3. Negative 3 times negative 4 is 12. That's 7. 7 times negative 4 is negative 28. That's negative 25. So again, the remainder is my answer. But let me check by plugging negative 4 into this equation on my calculator. Okay, so this one is negative 4 to the 3rd. Oh my goodness. To the 3rd. Plus negative 4 squared minus 5 times negative 4 plus 3. Yay, negative 25. Hooray. Okay, you can even check these ones if you want to. Like, you can kind of check anything by plugging the number into the equation. All right, these ones, it's just asking me to say whether these are factors or not. These are yes, no questions. And the way that we could tell if it's a factor, well, first of all, we have to use the solutions, which are negative 1 and negative 4, is you do synthetic division with the 0 of that factor. 1 times negative 1 is negative 1, that's negative 5. Negative 5 times negative 1 is 1 times negative 1 is positive 5. See, I'm really tired. Okay, 5 times negative 1 is negative 5, that's 4, and 4 times negative 1 is negative 4, that's 0. Because I got a remainder of 0, that means that, yes, x plus 1 is a factor. Okay? Now I'll do my next one with negative 4. So it was 1, 6, 9, 4. Okay. 1 times negative 4 is negative 4, that's 2. 2 times negative 4 is negative 8, that's 1. 1 times negative 4 is negative 4, that's 0. Once again, I got 0. So this one is also a factor. Okay, both of them were. All right, and on the test, you'll have a few where the page will say something like, you know, if it's a factor, go find some solutions, and if not, just put no. So if it's not a factor, you're just going to say no, okay? All right, this one I'm going to test negative 1. This one I'm going to test positive 1. Okay, so let me start with testing negative 1. Six times negative 1 is negative 6. That's negative 29. Negative 29 times negative 1 is positive 29. That's 73. 73 times negative 1 is negative 73. That's negative 100. So that is definitely not a factor, okay? When I do positive 1 into, put it over here, 6, negative 23, 44, negative 27. 6 times negative 1 is 6, that's negative 17. Negative 17 times 1 is negative 17, that's 27. 27 times 1 is 27, that's 0. So this one, since I got 0, the answer is yes, it is a factor. Okay? All right. Last couple of questions. The directions aren't exactly on here, but what it says on the test is check this factor to see if it's actually a factor or not. Okay? If it is, find the remaining factors. If it's not, just say no, it's not a factor. Okay? All right, now remember, for each of these, you have to use the solution that goes with it. So I'm using 3 into 2, negative 1, negative 23, 4, 60. Making sure I'm not missing any terms or anything. 2 times 3 is 6, so that's 5. 5 times 3 is 15, that's negative 8. Negative 8 times 3 is negative 20. Negative 8 times 3 is negative 24, so that's negative 20. And negative 20 times 3 is negative 60, so that's 0. Okay? So I would say that, yes, this is a factor, and then I'm going to keep going. All right? It'll be very clear what it wants you to do. And it says, let me remember if it says zeros or roots on the test. Zeros. Okay, so what you do is you take the numbers that are left over and you make an equation out of it. My equation is 2x to the third, because I started with x to the fourth, right? Plus 5x squared minus 8x minus 20. Now the first thing I can do with that is grouping. Okay, and in grouping, I can take out an x squared, and I'm left with 2x plus 5. And over here, I could take out a negative 4. They both have a negative, so I'm going to take out a negative 4. And I'm left with 2x plus 5. Okay, which means 2x plus 5 is one of my factors. Now, this other one, x squared minus 4, that can keep going. You always look if something can keep going. That's a difference of squares. X squared minus 4 is x plus 2x minus 2. And then we want to make sure that we do not forget about this factor from the beginning, the one that started us all off, you got to write that down here too. And so that factor is x minus 3. And then my zeros are negative 5 over 2, negative 2, positive 2, and 3. Okay, so you just write the factors and the zeros. All right, let's do these last two questions here. Okay, let's see if 1 is a factor of 291, negative 12. All right, 2 times 1 is 2, that's 11. 11 times 1 is 11, that's 12. 12 times 1 is 12, that's 0. So this is a factor. All right, I'm going to take these, I'm going to factor these out. Okay, it started with an x to the third, so this is 2x squared plus 11x plus 12. Okay, guys, now when you're factoring this, remember, you got to break this up. This is going to be like 2 and 1. Okay, got to break that up. Now it's either 1 and 12, 12 and 1, 2, 6, 6, 2, 3, 4, 4, 3. You got to try all these different ones. I think it's 3, 4. Yeah, because then that's 8 and 11, or sorry, 8 and 3, which makes 11. Okay? Don't forget about this guy. X minus 1 was the factor they gave you, so those are the factors. And then the zeros would be negative 3 over 2, negative 4, and 1. Okay? And here's our last one. We want to make sure that we're using negative 1 to see if it goes into 3, 5, 1, negative 1. 3 times negative 1 is negative 3, that's 2. 2 times negative 1 is negative 2, that's negative 1. And negative 1 times negative 1 is positive 1, and that's 0. Okay? Let's see here. This turns into 3x squared plus 2x minus 1, which factors to make, that can only be 3x and 3x when I split that up. That can only be 1 and 1. But to get positive 2, I need to go 3x minus 1x. So it's positive negative. Okay? And then we don't forget about this one. And so my zeros are 1/3, negative 1, and negative 1. Now, you are good to write negative 1 twice. I'm okay if you do that. Or you can write negative 1 with a multiplicity of 2. Okay? So hopefully that all makes sense. I think you guys are going to do great on your test. And hopefully that review was good. All right. Thanks. Bye, guys.